Can you hear me? Yes? Well, thank you so much for coming. It's such an honor to be in the first edition of the DConf. But before we start, I'd like to share something with you. I'm a big fan of astronomy, and here in Brazil, the winter has the most beautiful night sky of all the seasons. If you are in the south hemisphere during the winter, and you look at the sky at night, even if you are in a city with a high level of light pollution like São Paulo, you're probably going to see two very bright stars close to each other. These stars are Alpha and Beta Centauri. When I say these Greek letters, I'm telling you not only the name of the stars, but also giving you information about the intensity of the light of the stars in comparison with the other stars in the same constellation. So Alpha Centauri is the brightest star in the constellation of Centaurus. Beta Centauri is the second brightest, and so on and so forth. You're going to look to Alpha Centauri and trace an imaginary line that passes right through Beta. If you follow this line, you're going to find a cross. And this cross is probably the most important constellation in the South Hemisphere. It was so important during navigations that even nowadays, it's still on the Brazilian passport and in the Brazilian coat of arms. Its name is Crux, also known as the Southern Cross. But why am I talking about stars? Well, I have two certainties right now. First, before we leave this room through that door, most of you will have forgotten everything I told you about these stars. Second, even if you are in the southern hemisphere and you look at the sky at night, it's very unlikely you are going to find the cross only by following my instructions. Because it was too abstract, and this is not the best way to work with our brains. Because of that, I'd like to try one more time, but this time I will have a chat with your visual cortex. Now you're looking at the night sky in São Paulo. It's 21st of July, almost midnight. I will put the atmosphere back to help you out. Now, I told you we're going to find two very bright stars close to each other. Can you locate them? If you looked at this region, you're right, good job. This is Alpha and Beta, the brightest and second brightest. I also told you to start from Alpha and trace an imaginary line that passes right through Beta and keeps going down. If you follow on this line, you're going to find a cross. There are many other crosses in the sky. So just to make sure you know you are looking at the right constellation, I will give you two tips. This constellation has a fifth star, very tiny between Alpha and Delta. It's that one. In a free translation from the Brazilian Portuguese, we call it the meddler. It shouldn't be there. And the second tip is that starting from Alpha Crucis, the brightest star, which is this one, the intensity of the light of the stars is going to get dimmer and dimmer each time you move to the next star in the clockwise order. So we are going from Alpha to Beta to Gamma to Delta, always moving in the clockwise order. How does it feel right now? So much better, right? With visual clues, our brains process information faster and retain information for longer. And now that I have technology on my side, things can still get better. You're looking at the main lines of the constellation, so it's very easy to find the cross. We started with something abstract, moved to something visual, and now we have something even more precise. It's not showing the lines, right? Oh, sorry about that. Well, the next step must be sublime. Ladies and gentlemen, I present to you all the winter constellations. It's very hard to see. Okay, it doesn't matter. Let's go back to Earth. When I started to write a couple of years ago, I was eager to learn from the masters. What were the secrets of the authors I admired so much? And from the many tips I found on the internet, the one that puzzled me the most was the cryptic show, don't tell. I mean, writing is basically telling things, right? How could I not tell? But one day, out of the blue, it clicked. This clicked. We have just seen how different it was when I told you about the stars and when I showed you the stars. So let's make a deal now between you and me. From now on, if you're going to present your project to a prospective partner, show it, don't tell about it. If you're going to, I don't know, express your feelings for someone, show them, don't tell about them. If you want to know what lies under the surface of your applications, show, don't tell. My name is Artur. As a developer, I used to have a hard time to understand the cause of the problems in production. But my colleagues and I have discovered a way to learn about these problems in the blink of an eye, and that's what I'd like to share with you today. There are many channels where you can find me. I have a blog on Medium. This is my GitHub account, my Twitter account. And at the bottom, you'll find my email address. It will mean a lot if you write to me. It doesn't have to take too much of your time. Just drop me a line. You can send me a suggestion or a feedback or anything you feel like it. I'll appreciate that. And I work at Youse. Youse is the first insurtech of the country. It's a startup that aims to change how insurances are sold in Brazil. Before us, to buy an insurance policy, you would have to find an insurance agent. But I didn't have to talk to anyone to get a credit card from a new bank. If I want to go somewhere else, all I have to do is to open an app and call an Uber or a Cabify. Only with my cell phone, I can order food and clothes. I can watch series and movies. Why can't I do it with my insurances? Why can't I customize them in my own way and buy them in my own time? Why do I have to rely on someone else's so-called expertise? Youse is taking insurance policies made of paper from the bottom of people's drawers and putting them back in the palms of people's hands. I came here today to talk to you about monitoring. And I decided to talk about Grafana, StatsD, and InfluxDB because they changed the way we work. They pointed us in the right direction, and we would never, ever move as fast as we do today without them. I stand here in front of you to unveil our innermost secrets to move fast. And the secret is this. We measure everything. Our paths are laden with problems, and when they arise, the first place to run is the log. The log is straightforward when things are small, but when we start to scale, the more users we have, the more data we have to go through, and finding what you need is like staring at a well-stocked library, looking at the book titles, wondering which one could possibly have the information you need. I'd like to suggest an alternative. Let's go back nearly 1.5 years in time. It's now April 2016, and our startup is approaching the deadline of its first public release. Lots of things are still to be done, so we put some extra hours, we cut out functionalities. You have all been there, right? It's when we rush things that chaos ensues. Not only because we are tired, but also because we are so focused on delivering features that we are not preparing for failure. And then it strikes. There is this thing about bugs. They are always there, lurking around, waiting to bite us. So, okay, we are in production and something unexpected happens. What do we do? The author Rebecca Crane wrote in her fascinating book, The Odds of Love Grover Cleveland, that the only way to be found is to admit you are lost. And honestly, we were totally lost. As soon as someone discovered the bug, all the others started to run in circles. Hands raised, faces flushed, praying to all kinds of divine entities in dire expectation of a Deus Ex Machina solution. And we did that in loop until a blessed soul came up with a fix. It happened to us at Youse, and we learned important lessons back then. We needed better logs, sure, but it was more than that. We had to find a way to learn about these problems in an easy, self-explanatory way. And that's where our holy grail quest of measurements began. In our journey, we stumbled upon Etsy. Etsy is an e-commerce that sells handmade products. They have very interesting projects on their GitHub, and one of them is StatsD, which is a Node.js platform that collects data to build statistics. The biggest advantage of StatsD is that it works with the UDP protocol, which means it works in the fire and forget mode. There is no guarantee the package is going to be delivered. On the other hand, it's super fast. We are trading off accuracy for speed, so it can have almost real-time data of our applications. And they say that if engineering at Etsy has a religion, it's the church of graphs. If it moves, we track it. I also read in their blog that sometimes they track things that do not move yet, just in case they decide to make a run for it. And that was brilliant. That was precisely what we needed. This is Etsy's StatsD GitHub repository. But because we were doing Ruby on Rails, we needed a Ruby library to deal with it. And that's where Shopify's StatsD instrument comes in. It combines the power of StatsD with the simplicity of the Ruby language. The next item on our chain of measurements is Grafana, and here is where the magic happens. While StatsD is there to collect data, Grafana is there to help us visualize it. It's most commonly used to visualize time series data, not only for web, but also for analytics and IoT, for example. It has a very nice concept of pluggable panels, so you can build your dashboards in the way it befits you the most. We also need a place to store data, and for that we chose InfluxDB. But you do have other options like Riak or any other Cassandra-like database. And the result of this particular combination of this architecture is this. It's a beautiful, useful, colorful, very useful dashboard. Everything we need is here in one place. You can select what you want to see. You can select ranges of dates, ranges of times. You can drill down the charts. Everything's there. The only problem with this dashboard is that only by looking at it, we tend to believe that to code it, to build it, we have to code as if there is no tomorrow. But reality almost never agrees with our imagination, because what we need is really, really simple. When something happens, we count it. So, did the user purchase an insurance policy? We count it. Did the user change his or her password? We count it. We have to make a request to an external client. We count the time it takes to run, and that's it. That's all that there is to it. Believe me or not, this is all the code we use to collect data in our applications. If you are not aware of Ruby's syntax, fear not. It's very straightforward. You are looking at two main blocks of code. The one in the top is the measure method. It's used to calculate how long something takes to run. And the code we are measuring is the one in the middle. You can put as many lines of code as you want in there. In this example, we are measuring how long it takes to upload a file to our repository. The second block of code, it's actually one line of code, is the increment method. It counts how many times an event occurs. In this example, we are counting how many times the upload fails. And if you pay a closer look to both methods, you're going to see they have the same signature. Both accept the string as a parameter. Let's forget the comma and what comes after the comma for now. These strings are the names of the events. It's an identification you have to relate to when you are building your chart on Grafana. We tried to use this pattern of putting dots among the words because we wanted to plot different data in the same chart, maybe by using wildcards or something like that. It didn't work. To do what we wanted, we needed the tags feature, and tags is exactly what comes after the comma. You can put as many tags as you want in there, as long as they are in the key value format. And in both examples, we are passing as a tag the type of the document we're trying to upload. It was only thanks to the tags feature that we could build this chart. We have information about insurance policies, but with different colors for different products. It's very useful. Well, you must be eager now to see Grafana in action. I would be unquiet in your place to know how I could actually build a chart now that I have data in my hands. So let's stop everything and take a look at it. I created this dashboard called Lab. And the first thing to do is to add a row. There's only one button there, so I click there. And I select Graph. You can see it automatically created a chart with fake data. Everything I change here updates this chart so I can see what's going on. I clicked on the panel title. It gave me these options. I went to the edit. So you are looking at the chart, and there are some tabs below. And the first place to go is the metrics tab. First, I want to get rid of the fake data. And you can do that by clicking on the trash can. Here, it's this button. It's very hard to see. Okay, I click there. The data is gone. First, before starting building the chart, I went to the General tab and put a more meaningful name to it. So instead of panel title, I chose Documents Upload. Now back to the Metric tab. The first thing to do is to tell Grafana what is your data source. And for me, it was InfluxDB, so I just select it. I'm ready to start adding queries. And to do it, I just click on the blue button. It opens some fields. It looks a lot like a SQL query. And you can change the query by clicking on the fields you want to change. So I started by clicking on Select Measurement. And I typed only a part of the name of the event. That same string we passed on the Ruby method. So I typed the document upload, it's the one in yellow, and it lists to me all available events that match that pattern. It takes only one event of a given name to put it on this list. I selected document upload to repo succeed. And I don't know if you can see, but there is already some data in here. It's very light. Now I'm ready to start filtering data. And I will use tags, and to do that, you can just click on the plus sign after the where clause. It gave me again a list of available tags, and once again, it takes only one event with a given tag to put the tag on the list. There are 3 tags by default, with DC, host, and metric type. But the tag I created is there, document type. For the value, I chose insurance policy. Now, in the select clause, I always use the aggregation mode of sum. I will explain why later on. It's not that important for now, so let's just stick with the sum. I will go back one slide here. If you see here in the legend of the chart, it assumes the name of the event as the legend. So here there is an alias by, and you can put a more meaningful name, something more friendly to help users to understand what's going on. So I have already a query here. We can almost, actually we can't see anything. There are just 2 lines in here that you probably can see from there. And the problem is we are looking at the last 6 hours. I didn't have too much data in that period. There is a link up here. It's cut by the screen. If you click there, you can select another period. And I selected yesterday instead of last 6 hours. And now my chart is a little bit better. It's kind of confusing. I tried to go to the display tab and change from from lines to bars. It's not perfect yet. We will get there, but for now I think it's good. So I went back to the metrics tab, and I want to add a second query. I could have simply duplicated the first one and changed what I wanted to change, which is just the value of the tag. But for the sake of the presentation, I did it from scratch. So I clicked on the blue button. It opened a new set of fields. I clicked on select measurement, typed the same name of the event. It gave me a list. I select the same tag, but for the value, this time, I put cancellation letter. Again, the aggregation mode of sun, and an alias to improve the legend. And you can see there are some yellow lines in the chart right now. The problem with this chart is that I can't take decisions on it. It's very confusing. We have too much data between the hours. So if you go at the bottom of the metrics tab, you can see we have a field to group data by intervals. And in this field, I grouped the things by chunks of 1 hour. And now the chart is a whole lot more useful. If you want to, you can even go back and change 2 lines again. It's much more easy to use this chart. And if you save it, it's going straight to the dashboard. It's very straightforward, very quick to create a chart. I think it took me like 3 minutes to build this chart, stopping to take the screenshots. Okay, we know what parts of the architecture we need. We know how to code it. We know how to build the chart. But the question that remains is it really helpful? I mean, it's very beautiful on screen, but did it really help our company? And the answer, as you might have already guessed, is a big yes. You are looking at a real dashboard. It's the sales funnel for our live product. There is a red vertical line somewhere near the middle of the chart in here. It represents a deploy in production with something clever to track. And all the other lines are pages in the order flow. We are tracking each page the user is passing by. Actually, after the deploy, all the lines started to dance above the average, so it seems we put something good out there. But one of our developers was looking at the chart, and he saw something weird was going on. Can you see this light blue line over here? During the deploy, it went to 0 and never came up again. What happened? I will give you a little bit of context first. At that time, we were changing a little bit how we were calling StatsD methods. Instead of simply calling the methods, we were dispatching an event to an internal message broker to let things be dealt with in background. Something like this. This is the normal flow of the code. It could be a controller or a model. And when we felt we had data, we broadcast an event. And there was a listener listening to this event. All the methods of the listener, are just calling StatsD. It seemed to make sense for us at the time. We were centralizing StatsD in the same file. But in time, we started to see there were no advantages to this approach. It was just creating an extra layer of indirection, an unnecessary complexity. So we decided to take it off the message broker and simply call StatsD, like this. The problem is, while we were working on this change, all the other teams were still working on their own features using the pub sub. And the live squad had to split the first page in two. Each page received its own increment method, but using the pub sub. When we finished our changes, we committed to GitHub repository. There were conflicts in the first page and went there and changed it again. But we didn't change the second page because that page didn't exist for us. It was a blind spot. Actually, I'd like to stress something important here. It was a developer who was looking at the chart and analyzed its data, not a manager or someone from sales or from marketing. Information should not be for the privileged few, made only for the eyes of those high in the hierarchy. None of what I said up to now is going to work if you keep information secret. The monitoring system unveiled to us problems that were happening under our very feet. When the user tries to purchase an insurance policy, we have to know if he or she represents a risk to us. And in order to do that, we contact a service called Crivo. Crivo then checks a gamut of sources to gather all information that's possible to get from a person. However, one of these sources was misbehaving. We can never live in peace. It was randomly returning the code for a fraud, which was a valid code. We were expecting to receive it at some point. But the only way to know that the number of frauds was too high was if you were looking at the logs 100% of our time, which is completely impractical. As soon as we created the dashboard, we contacted the service to have it fixed. But we also came up with a feature on our own that changed how we were dealing with failure. Before this feature, when a problem happened in the order flow, we stopped it, preventing the user to move forward. Now, we assume the failing service would return with success and let the user move on. But at the end, instead of creating an insurance policy, we create a proposal which can be valid up to a fortnight, buying us time to recheck the failing service. Thanks to the monitoring system, we improved the user experience and we stopped losing sales. You are looking now at a screen record of the user selecting a vehicle in the order flow. But we do not work with all makes and all models. So if you go there and select a Jimny from Suzuki, for example, you're going to receive an alert saying, oh, I'm sorry, but we do not work with Jimny yet. And you can type your email address and we will alert you when we start to work with it. But we wanted it to be a little bit more predictive and to attend to the user's needs. Because we were tracking this information, we could create this chart. And we can know very quickly how many times a vehicle was refused for being too old or too expensive, or of a make or a model that we do not accept yet. This is very useful because the next time you are choosing a vehicle to work with, we are no longer guessing. We are doing it based on data. This is what's called to be data-driven and user-centric. From the beginning of this year, I have been working on a geolocation system. It's called Youse, which stands for Geographic Information System. From the very beginning, we wanted to offer a product that really related to the users. But to be honest with you, before this, all we had was a one-size-fits-all kind of product. But the thing is, when you purchase an insurance for your house or your apartment, these things are in a fixed place. We can learn about these places beforehand. So if you go there to our website and type your address, we can know, for example, the square meter value of your neighborhood. We can know if the level of robbery and theft in the area, or if there is a chance of natural disaster in there. We can know if your house is near an airport. And based on this data, we can suggest the best coverage the user can have. When someone purchases an insurance policy, we have to warn this so it can update its own database. And it stands to reason that when someone cancels an insurance policy, we also have to warn this. I was building the dashboard for this service. It's the one we're looking at. And you can see the line of new insurance policies here. It's working pretty well. But the line for cancellations is empty. The monitoring system is good because it makes us think out of the box. Does it mean we didn't have a single cancellation in the last 24 hours? Or do we have a problem in the, between the systems? I presented to you 3 tools that you can combine to build a monitoring system. But honestly, the tools are not important. I don't care about them. I'm only concerned with the mindset that we need to see. We need the light of the stars to guide our path. You can substitute tools, you can remove them if it makes sense to you. And in fact, we did a change in our architecture at Youse. We use StatsD protocol and StatsD idea, but not the Node.js platform. We are sending data straight to Grafana through something called Telegraph. It works. If you intend to do the same thing, there are 2 things I have to warn you so you don't waste time looking for a problem. The first thing is that Telegraph will convert dots to underscores in the name of the events. I don't know if you saw on the screenshots when we were building the chart on Grafana, but when I typed document upload, there were no dots in there, only underscores. That's one of the reasons wildcards would never work in there. The second tip has to do with the aggregation mode of SUM. Telegraph does not flush data to the database as soon as it arrives to prevent performance issues. So let's say it's collecting data. It has like 7 events. When it decides it's time to flush, it's going to create 1 entrance in the database with the number 7. If in the query you use the count, which is the most intuitive thing to do, it's going to count the 7 events as 1. So that's why I always use the sum. You might be wondering where to go from now, so I put here some resources that might be helpful. The first one is influxdata.com. They have tons of information about each one of the tools I told you today and others you can use instead of them. It's a very good start point. Start from this website. Then I put GitHub repositories for both Etsy and Etsy StatsD and Shopify's StatsD instrument. It's those I told you at the beginning of the presentation. The fourth link is codascraft.com. This is Etsy's technology blog. They are masters of monitoring. I highly recommend you to go to this website. There are many articles. It will take a time to read everything, but it pays off. Grafana.org is the official website for Grafana. And last but not least, Youse Technology blog. If you want to know what we are working on, go to labs.youse.com.br. It's Portuguese only, though. All of it was only possible because of the open source. There are amazing tools out there that you can combine to solve your needs. When you do, share. Share so others can know about it and use it. Or even better, so others can improve it. Youse was certainly not the first to build its monitoring system out of these tools, nor will it be the last. It was only possible because others shared what they learned along the way. So now it's my turn to pass the torch. Go out there and build glorious things, but when you do, come back and share. In a world that needs speed and precision, do not neglect the power of visual clues. The faster we know what's wrong and where to put our efforts, the better we are going to grow. From mapping the health of your applications to guiding yourself with the stars, all you need is to see. Remember, show, don't tell. and you can take a glimpse at your applications, or you can truly see them. The choice is in your hands. Thank you very much.